So in today's session, we are basically going to do some revision numbers on CIE Cambridge International Examinations. That is general physics, and the subtopic we are going to concentrate on here is length and time. So we're going to do some numbers on length and time. So without wasting any more time, we will get started. My name is Arnold Rangakuramia, and this is Kisembo Academy. So we'll go straight away with question 1 here. The diagram shows an enlarged drawing of the end of a meter rule. It is being used to measure the length of a small feather. What is the length of the feather? So if you look at this question here, this is the feather. It's starting from here. If I might draw the line, it's starting from that point. And this point here, according to this meter rule, we have the meter rule has units in millimeters and in centimeters. So as far as millimeters are concerned, this is the first top here like this, then centimeters are below here. So it is running from from 10 here, 10 millimeters, which is the same as 1 centimeter. And at the end here, we can see that this moves down here up to around there, and from here it's probably not exactly reaching here, but if this is 20, this is 21, 22, 23, 24, this is 25 millimeters, 26, 27, 28, it is close to 29 millimeters. From here you can see that it's around there, it's coming to 29 even here at the beginning. So 29, but remember that if this is 29 millimeters here at the beginning, this is not 0, it's 10. So to get the length of this, we shall say it is the final length, which is 29 millimeters minus 10 millimeters, and we shall end up with 19 millimeters. So meaning that's the length of this. So as far as millimeters are concerned, it's 19 millimeters, and if you are to convert this to centimeters, it is 1.9 centimeters. So we move to our answers. Our object here, from what you can see, what's the length of the feather? Our answer is A. It is 19 millimeters. In our next question, they are saying which measurement can be made using a micrometer screw gauge. Now we all know how a micrometer screw gauge looks like. It measures very small lengths, and from here our answer is B. It can measure the diameter of a wire. Now, a micrometer screw gauge is actually used very widely in mechanical engineering, and it is used to measure precise measurements of very small objects. And this involves, the depth or the length or the thickness of whatever object that can fit between the anvil and the spindle. Besides just the diameter of a wire, a micrometer screw gauge can also be used to measure the thickness of a metal sheet. Moving on to the next number. In this question, that a geologist compares the volumes of 3 rocks. We have rocks X, Y, and Z. So they are right here. X, we have Y, we have Z. 3 measuring cylinders contain different volumes of water. He places each rock into one of the measuring cylinders. The diagrams show the measuring cylinders before and after the rocks are put in. So we are looking at the rocks right there, before and after they are put in. So the question says which row shows the volumes of X, Y, and Z in order from the largest to the smallest. So we have rocks X here, X, Y, and Z. Let's first find the size, the volume of each of these rocks. Now, when we see this thing before, it means that this water was poured into this measuring cylinder before, then the rock was put in, and now we have the water rising up to somewhere afterwards. This method of finding volume of irregular objects is what we call the displacement method. This is the displacement method for finding volume of irregular objects. And the formula for finding this is that we are going to get the water level after putting in the stone, and then the water level before. We are going to subtract these two, and the balance is the volume of the irregular object. In other words, when we dropped this stone into this water level was able to rise because water was displaced here. This stone displaced some water and it caused water levels to rise. So the difference between the new water level and the original water level is what is going to give us the volume of this stone, or call it the volume of the irregular object. So we're going to go ahead and begin. Let me call this finding x. So before the first water level at for x here, stone x, this is 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70. So here at first the new reading was 70, then the old one after, then the old one here was 20. So it is 70 minus 20. 70 minus 20 is 50. So the volume of the stone x is 50 right there. And it's all in centimeters cubed. We're able to see that from up here. Those are the units. 50 centimeters cubed. So this is centimeters cubed. Then moving on to the second stone y, irregular stone y. We are still using the same cylinder, which is centimeters cubed up here. So coming here, it is 70, 71, 72, 73, 74, 75, 76, 77, 78. So we have here 78 as the volume minus the volume of the water level before this stone was put in, which is 20. This is 25, 26, 27. This is 27. So it becomes 78 minus 27. When we subtract those two, we end up with 51 centimeters cubed. So 51 centimeters cubed, that is y, the volume of stone y. Then finally, we have here the initial volume here. I mean the volume of the water level after the stone was dipped. This is 70, 75, 76, 77, 78, 79. So this is 79. So in other words, we have 79 here, the volume after. So before dipping in, coming here, it is 30, 31, 32, 33. So this is 33. So right here, it is 33. When we subtract these two, we end up with 46. And this is the volume of Z. The question wants us to organize this to show the volumes of X, Y, and Z in the order from the largest. So from the largest, from here we can see that the largest is Y. So the largest is Y, followed by X, followed by Z. So if this is the order from the largest to the smallest, when we come to our objectives here, our answer should start with Y, then X, then Z. And so our answer is B. So moving on to the next question, the diagram shows 4 identical spheres placed between 2 wooden blocks on a ruler. What is the diameter of one sphere? So to find the diameter of one sphere. So from here, we can look down here at this meter rule. We need to know how the least count. I think from here, if you will count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So meaning that this ruler down here, it's increasing by 1 centimeter. Okay. So we have two spheres here. They are touching each other, right? And there are four of them. The beginning count here is this is 4 centimeters here. So it's beginning from 4 and it is all running to 10, 11, 12 right there. So this is the length that is covered by these spheres right there. We are being required to find the diameter of each one. Remember, the question says that the diagram shows 4 identical spheres placed between two wooden blocks. So meaning that this is diameter. They're identical, it means that this diameter right here is the same as that diameter. It's the same. It's also the same as that diameter. It's also the same as that diameter, right? These values of the diameters of these spheres are the same. So meaning that if we are to add these diameters are equal to 4 diameters. However, they are covering this length from there up to there. So what's this length? Remember here this is 12 centimeters and right here it is 4 centimeters. So to get this distance here, it is going to be 12 centimeters minus 4 centimeters, and that's going to give us 8 centimeters. So meaning that in between here, this is 8 centimeters long. So it means these 4 diameters, 1, 2, 3, 4, this 4D is covering 8 centimeters. So we can simply come here and say that 4D is covering 8 centimeters. But me, I'm interested in finding the diameter D, because that's the question. What is the diameter of one sphere? So this is the diameter of 4 spheres covering 8 centimeters. If I divide both sides by 4, this goes with that, you end up with D as by 4 once, by 4 twice, so 2 centimeters. So each diameter is 2 centimeters, so the answer here is B. So moving on to the next question. A cook wants to prepare some food to be cooked by 1:15 p.m. He uses an oven with an automatic timer that can be set to switch on and off at certain times. The oven needs to be switched on for 2 hours and 10 minutes. So I need to switch on the oven for 2 hours and 10 minutes. In other words, if you switch it on for 2 hours and 10 minutes, it eventually will go off. Okay, the oven needs to be switched on for 2 hours and 10 minutes. At what time does the oven need to switch on? So if the food needs to be cooked by 1:15, so by 1:15 the food needs to be cooked by 1:15, and this oven needs to be switched on for 2 hours and 10 minutes. It means that if by this time this oven is supposed to have cooked the food, and this oven is supposed to be on for 2 hours and 10 minutes before it goes off, then it means you're going to get this time by which the time by which the food needs to be cooked, and we count backwards 2 hours and 10 minutes. In other words, if this is the final time, or if we are saying that by this time the food is supposed to have been cooked, then if the oven should be on for 2 hours and 10 minutes and they're asking us at what time or at which time does the oven need to switch on, then we're going to count backwards from this time. Now, if you realize this time is in 12 to 20, converting this is PM. Converting this to 24-hour clock would be, let's put it, of course, converting this to 24-hour clock is going to be 15 hours. So we convert that to 24-hour clock, then we subtract this time the oven is supposed to be on, and we see at what time it lands. The question says that the oven needs to be switched on for 2 hours and 10 minutes. So if by this time the food is supposed to be ready, let's count backwards 2 hours and 10 minutes. So after converting this to 24-hour clock system, let me get rid of this. So 24-hour clock system, we are going to go ahead and subtract the 2 hours, remember this is hours and this is minutes. 2 hours and 10 minutes. We subtract. So here we shall come and say 15 minus 10, you remain with 5. This is in the minutes. Then in the hours, it's 13 minus 2, we have 11. So in other words, it's at 11:05, the stove must have been switched on. 11:05 hours, which is the same as AM in 24-hour clock, in 12-hour clock system. So if you're to come here, 11:05, what answers do we have? We have at 3 p.m., at 3:25 p.m. These two can't work because this is the time after 1:15. The question says the cook wants to prepare some food to be cooked by 1:15. It means by 1:15 the food should have been prepared. So it can't be after. So looking at answers A and B, we have this answer 11:25. Now if you're to say 11:25 and you're to count 2 hours and 10 minutes after 11:25, it will mean that by 1:15 the stove will still be on, the food will not have been cooked. However, if the thing is switched on at 11, well, the answer here we've gotten is 11:05. So meaning either the stove is supposed to be switched on at exactly 11:05 a.m. so that the food is ready by exactly 1:15, or you're supposed to switch on the stove earlier than this time so that by the time you reach 1:15 the food is ready. And from all these answers, this is the most practical answer. If you switch on the stove at 11, it means that according to our calculation here, the food has been switched on. The stove was switched on 5 minutes earlier. So if you're switching it on earlier, it means that by 11 the food will be ready, because the question says a cook wants to prepare some food to be cooked by 1:15 p.m. So I mean by 1:15 p.m. the food will be ready. So the answer here is A. Which option contains only apparatus that can be used to determine the volume of a small block of an unknown material? Remember, the small block, unknown material, we've just done this before. We need a measuring cylinder, and from what we have here, we need a measuring cylinder when we are measuring, we are measuring volume of a small material of an irregular object. So measuring cylinder, it's either A or B, but here meter rule and balance, no. Meter rule and stopwatch, no. So measuring cylinder, then stopwatch, we don't need a stopwatch. Meter rule, measuring cylinder and meter rule, yes, because we need the measuring cylinder to measure the object where the water is going to be. Now maybe if this cylinder is not graduated, then you'll need the meter rule here to be able to measure the depth of the water. So our answer here is A. The diagram shows a measuring cylinder used to measure the volume of a small stone. What is the volume of the stone? This is the displacement method of measuring volume, and from here we can see that the volume of the water after the stone has been dropped, this is 10, this is 20. We need to find out this is increasing by how much. If we say 10, 11, 12, 13, 14, 15, no, this is not 15. So we try 10, it's after every 2 graduations. So 10, 12, 14, 16, 18, 20. So it's increasing by 2. So 20, 22, this is 22, 24, 26. So this is 26 right there. And then this is 10, 12, 14, 16, 18. Here it is 18. So the volume of the water after is 26 minus the volume of the water before dropping in the stone is 18. When we subtract those two, we shall end up with 8 centimeters cubed. And so it means our answer here is A. That's the volume of the stone, 8 centimeters cubed. A student uses a measuring cylinder to measure the volume of a quantity of water. What action would make her result less accurate? So it's about less accurate. So making sure her eye is at the same level with the water surface. Of course, when you are measuring water, if this is the cylinder and that is the meniscus and that's your water right there, for you to make sure that you're measuring accurately, yes, your eye level should be around there. It should be at the same level. So it means this is your eye. So this makes it accurate. So that can't be the answer to make the result less accurate. Then we have making sure the cylinder is vertical. Yes, when the cylinder is vertical, it gives you accurate results. Reading the bottom of the meniscus. Yes, this is the meniscus right here, and you're supposed to read the bottom right there. So the bottom of the meniscus is the correct reading. That is true. Then D, using the largest measuring cylinder possible. Of course, if this is a cylinder and I have another cylinder here that is thinner, and I pour in the same volume of water, I put my eye here. This is a big cylinder and this is a small cylinder. The truth of the matter is that I am more likely to get a more accurate result using a smaller cylinder or a narrower cylinder than a big one. So this will be more accurate. This will be less accurate. Because now when this surface area is big, I'm not able to accurately read the lower part of the meniscus because the lower part of the meniscus also becomes wide. But when I am using a smaller one, like this one, a smaller measuring cylinder, I'm able to easily look at the meniscus bottom closer to the graduations and I'm able to get a more accurate result. So what action would make her result less accurate? Using the largest measuring cylinder possible. Okay, so moving on, a student uses a measuring cylinder to measure the volume of some water. Yep, the diagram shows part of the measuring cylinder, the top and bottom of the meniscus are calibrated. Yes, what is the volume of the water? So again, like I have been explaining in our previous question, that when we are measuring the volume of the cylinder, we are supposed to read the bottom of the meniscus, not the top, but the bottom. This is what is supposed to give us the answer. So from here, we can say this is 40, that is 41, 42, 43, 44, 45, 46. Oh, no, this is 40 right there. Then we have 45. So in between is 40, then we have 41 here. Then we have 42. I think we are supposed to have something there. Then we have something there. This is 43. Then we have 44. Then we have something there. Then 45. So it is more like it is 40, 40.5, 41, 41.5, 42, 42.5, 43, 43.5, 44, 44.5, 45, 45.5. Then we have here 46. 46.5, then we have 47 right there. Here, this is 47. So that is the answer. So our answer here is A. Then finally, a student wishes to measure accurately the volume of approximately 40 centimeters cubed of water. She has two measuring cylinders, a large one that could hold 100 centimeters cubed. This is the large one that can hold 100 cc, and a smaller one that can hold 50 cc. And we want to measure 40 centimeters cubed of water right there. The water forms a meniscus where it touches glass. Which cylinder should the student use and which water level should be used to ensure an accurate result? Remember, we said that in this case, for example, to get more accurate results, you need to use a smaller cylinder. And on top of using a smaller cylinder, you're supposed to read the bottom of the meniscus. So which cylinder should the student use and which water level should use to ensure an accurate result? To ensure an accurate result, you need a smaller cylinder. But between the smaller cylinders, you need to be reading the bottom of the meniscus. So meaning the answer is C. So that will be it for this revision video where we have covered basically the length and time questions in Cambridge International Examinations. In our upcoming sessions, we shall be covering more and more topics. If there are some topics that you want me to cover in this kind of style, just let me know about it in the comment section below. My name is Arnold Rangakuramia, and this is Kisembo Academy. Take care.